The cylindrical disk method is a mathematical technique used to calculate volumes of solids formed by rotating a curve around an axis. It involves dividing the solid into infinitely thin cylindrical disks and integrating their cross-sectional areas along the axis of rotation to determine the total volume. So what does all that mean? Well, consider the following function. The function shown is y equals negative 3x squared plus 18x take away 24. If we were to find the solid formed by rotating the area trapped between the function and the x-axis, one full revolution around the y-axis, we would get the following. So looking at it from the side, the cross-sectional view, it would look like that. Looking at it from the top, it looks like that. So it's a bit of a funny shaped donut type structure. Now we're going to look at doing this by this method using the cylindrical disc. But the way that you might do this, and the way I approached it for the one in the exam, is find the vertex there and then use the equation of this side and rotate that around the axis, and then use this side and rotate that around and subtract it. So that's the alternative. But we're going to look at this new method. So what we're going to do is now consider the solid being made up of lots and lots of empty cylinders of different heights. So there's a cylinder drawn on this diagram here, but this view really shows it well, where you're looking down and you've got all these cylinders. And just like what we've done in the past with rectangles, and we end up with an infinite number of infinitesimally thin rectangles, that's the idea here. We're going to end up with these infinitesimally thin disks. The volume occupied by each individual cylinder is given by volume is the circumference times the height times the thickness of the cylinder wall. And of course it's that thickness that was the thing that we're going to tend towards 0. So it looks something like these stacked cylinders here, where the radius of the cylinder is x, the height is f of x, and the thickness of the cylinder wall is dx. So we're tending that down towards 0. So the volume is 2 pi x times f of x times dx. We can then use integration to add together all the cylinder volumes to find the volume of the solid. So it's going to be the integral from a to b of 2 pi x f of x dx. For the situation on the previous page, v is going to be 2 pi x. We're integrating from 2 to 4. If we just go back up here, we can see the 2 to 4 just there. And then we have the function itself. That's the f of x, negative 3x squared plus 18x take away 24, and the dx. 2 pi is a constant, we can take that outside, multiply the x into the function, and we can see we get negative 3x cubed plus 18x squared minus 24x dx. You know how to evaluate that integral, and if you do that, you get 24 pi cubic units.